Alright, one other concept that we're going to use that's going to help us out a little bit on finding these real roots or finding our zeros is the idea of conjugate pairs. Now, as far as this goes, what's going to be talked about here is if we have a complex zero. So let's say that we have a plus bi. If that is one of our zeros, then a minus bi, its conjugate, also has to be a zero. So if this is going to be a zero, this has to join it in a pair. Okay? So that's going to be the first thing that we're going to deal with. And that's going to really help us out in solving some of these problems if they're giving us a few things. So if they were to tell us that 3 plus 2i is a zero of our polynomial, then we know right away 3 minus 2i is also a zero of our polynomial. So we're going to keep that in mind as we do one of these problems. So here's what our first problem is that we're going to take a look at. And we're going to keep this conjugate pairs idea in mind. They're going to they're going to give us the fact that some polynomial has zeros of -1, -1, and 3i. Now what they want us to do with this information is find a 4th degree polynomial and there's going to be a couple things that we can look at on here. We know a 4th degree means it's going to look like f of x equals some constant potentially, and then x minus c1, x minus c2, x minus c3, and x minus c4. So when I'm done, if I write it in terms of linear, it should have 4 factors, and potentially it could have a factor out here. Now, because this could be a lot of things and we're not given enough information to take this any further, all we're really going to say is, for this problem, let's assume that a is a 1, just to make it simpler. Alright, so let's start this one up. So our f of x, 1 is coming from the linear factor, or -1 is coming from our linear factor x plus 1. Because remember, if I set this factor equal to 0 and solve it, I would get -1 as a solution. There's 2 of those. There's also a 3i, which is coming from x minus 3i. And remember, like we said, conjugates are conjugate pairs. So the conjugate of 3i is -3i, which means that's coming from x plus 3i. So in other words, if 3i is here, -3i has to pair with it. So there's our 4 linear factors. Alright, so what we're going to do with that, simplify. So we can take this one, which is the same as x plus 1 squared, so I can actually just do square multiple square, and I can get x squared plus 2x plus 1. In this part, we worked with conjugates, and we had a shortcut for doing conjugates of complex numbers, where we said we squared the first, we squared the last, and we added. So x times x is x, 3 times 3 is 9, and we always do addition when we're doing complex conjugates and multiplying them together. So that's where we're at so far with our f of x. Now we just take it another step, and we're going to do some distributive work here. So I'm going to distribute the x, oops, that should be x squared. I'm going to distribute x squared on this, and get x to the 4th. X squared times 2x is 2x to the 3rd. X squared times 1 is x squared. Then I'm going to distribute my 9. 9 times x squared is 9x squared. 9 times 2x is 18x, and 9 times 1 is 9. So I can put that all together with like terms, and I'm going to get x to the 4th plus 2x, and again my board's not writing here very well for me. 2x to the third. Both of these are x squared, so we'll do like terms. 10x squared plus 18x plus 9. So there is my fourth degree polynomial. It had the three given zeros and our assumed fourth conjugate pair to make up our four linear factors. So this would be my solution. Now as far as that a out front, that constant, they could have given us a little bit more information, and if the a was a 2, all of this would be doubled. A was a 1/2, all of this would be times a half, and so on. For this one, we just made the assumption that it was 1, just because they told us to find a fourth degree polynomial, and they didn't give us really any more information to go on. Alright, let's take a look at a second type of problem that we can do that's going to involve conjugate pairs. And this one they're going to give us a little bit different information. So this one they're going to tell us that f of x equals x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60 is our polynomial. So there's our polynomial. Now the only thing that they're going to give us on this one is they want us to find our zeros if we know that 1 plus 3i is one of the zeros. So right now we only know one of them. Since it's a fourth power, we know there has to be three other ones. So let's take a look at this. Remember, this itself is a 0, and remember that a 0 is actually going to come from x minus c. So in other words, this 1 minus 3 or 1 plus 3i is our c value. So if we set that one up out here, x minus 1 plus 3i, there's one factor. Now again, because of conjugate pairs, we know that 1 minus 3i also has to be a 0. So if I put that in this same situation, my factor would be x minus 1 minus 3i. So we're taking each of our zeros, 1 plus 3i and 1 minus 3i, and subtracting them from x, and that gives us our factor. Now, there's some simplification I can do here. If I want to just distribute the negative here and here, and the negative here and here, and get two different trinomials to work with, and do distribution 9 times, and then try and simplify to see what this reduces to, I can. But this one, I can also use order of operations, where it just says I've got a subtraction here, I've got an addition here. They're my only two operations inside the first set of brackets, so I would go left to right anyway. So I'm just going to replace or reposition my parentheses, and you'll see why in a second here, and do the same thing for my second bracket. All of a sudden, my x minus 1 becomes my a, and then I've got plus bi, and here I have minus bi. The b is 3 in both of them, so I've got a multiplication of conjugates. And again, our shortcut for that said, take a, which is x minus 1, square it, take b, which is 3, square it, add those two things up. So once I do that, I can do square multiply square here. And then do 3 squared, which is 9, and add that 9 to the one that's already here, and I get 10. So that does a little bit of good, because now that tells me that this part up here, these two zeros gave me these two factors, which ended up giving me this as another grouped factor. So if I want to solve the rest of this, I'm just going to do a long division. So we'll switch the colors up here so we can keep track of our steps. So I'm going to take this x squared minus 2x plus 10 that we just found, and we're going to let that be the divisor of our original polynomial. The x to the fourth minus 3x to the third plus 6x squared plus 2x minus 60. So let's see if we can remember what we were doing when we did long division. It's been a few different videos back, but it's here. So on this one, we look at our first term, and our first term, x fourth divided by x to the second is x squared. Do distributive. This time we're just going to have to distribute 3 times. So we're going to get x to the fourth minus 2x to the third plus 10x squared. And again, if you remember how I've done this in the past, I do draw the line, change the signs, so we don't run into trouble with people forgetting to do minus a minus and so on. Opposites go away. I'm left here with negative x to the third, and here I get negative 4x squared. And then we bring down our last 2 terms, plus 2x minus 60. Go to our next step, which says take first here and see if it'll divide into the first here, which it obviously does. So negative x to the third divided by x squared is negative x. Do my 3 distributions again. Negative x times x squared is negative x to the third. Negative x times negative 2x is going to be positive 2x squared. And then negative x times 10 is negative 10x. Go through our steps again, draw the line, change my signs. Opposites cancel. Here I get negative 6x squared. And here we get plus 12x. And then we subtract 60. So we do it one more time. First term here, first term here. Negative 6x squared divided by x squared is negative 6. Do my 3 distributions. Negative 6 times x squared. Negative 6 times negative 2x. And negative 6 times 10. Draw my line, change my signs. And everything canceled, so I had a remainder, which is nice because then that tells me that x squared minus x minus 6 is another factor. So we're going to add that over here. And the nice thing about this, easily factorable, x minus 3, x plus 2, and then I can set each of these equal to 0, and this is going to let me find x equals 3 and x equals negative 2. Put those with the 2 values that came from this, which is x equals 1 plus 3i and x equals 1 minus 3i, and there we have the 4 roots that we were trying to find for our zeros. A lot of work, but it still goes back onto some basic concepts with those conjugate pairs.